Hi, today I am going to solve two problems using the method of induction. The method of induction is a very powerful tool to solve and to prove mathematical propositions. Now it is basically that let's have a statement T. Now this statement T, let's say it's true for we know that it's true for Tk. Now suppose it's true for Tn, then if I can prove that it is also true for Tn plus 1, then we know that this statement T is true for all positive integers greater than or equal to k. Now let's look at for a problem which can be solved using the method of induction. We have to prove that 2 into 7 to the power n plus 3 into 5 to the power n minus 5 is divisible by 24 for all n greater than 0. Now let fn be 2 into 7 to the power n plus 3 into 5 to the power n minus 5. Now and let Tn be the statement 2 into 7 to the power n plus 3 into 5 to the power n minus 5 is divisible by 24. Now we have f1 to be 24, therefore T1 is true because 24 is always divisible by 24. Now let Tk be true for any value of k, and therefore the fk or the expression 2 into 7 to the power k plus 3 into 5 to the power k minus 5 is divisible by 24. We have to prove that fk plus 1, that is 2 into 7 to the power k plus 1 plus 3 into 5 to the power k plus 1 minus 5 is divisible by 24. Now for fk plus 1 to be divisible by 24, the difference of fk plus 1 and fk have to be divisible by 24. Now the difference is 2 into 7 to the power k plus 1 plus 3 into 5 to the power k plus 1 minus 5 minus 2 into 7 to the power k plus 3 into 5 to the power k minus 5. Now writing 7 to the power k plus 1 as 7 into 7 to the power k, and similarly writing 5 to the power k plus 1 as 5 into 5 to the power k, and simplifying it, we get this expression to be 12 into 7k plus 7 to the power k plus 5 to the power k. Now we know that 7 to the power k is an odd number and 5 to the power k is an odd number too, because any power of 7 and 5 will always be odd. Now the sum of two odd numbers is always even, therefore 7 to the power k plus 5 to the power k is even. Therefore 12 into 7 to the power k plus 5 to the power k is divisible by 24, as 7 to the power k plus 5 to the power k has at least 1 2. Therefore if k plus 1 is proved, is divisible by 24, therefore all numbers greater than 0 of the form 2 into 7 to the power k plus n plus 3 into 5 to the power n minus 5 will always be divisible by 24. Now let's look at another problem. We have to show that x minus 1 whole square is a factor of x to the power n minus nx plus n minus 1 for any n greater than or equal to 2. Now let T be the statement x minus 1 whole square is a factor of x to the power n minus nx plus n minus 1. Now we have T2 to be x minus 1 whole square is a factor of x square minus 2x plus 2 minus 1, substituting n as 2. Now this is always true as this itself is x minus 1 whole square. Now let Tn be true for any n. We have to prove that Tn plus 1 is also true. Now this is same as proving that the expression by if we have Tn is true means x minus 1 whole square is a factor of x to the power n minus nx plus n minus 1, and we have to prove that x to the power n plus 1 minus n plus 1 into x plus n plus 1 minus 1 is a factor of x is a multiple of x minus 1 whole square. This is only possible when their difference is also divisible by x minus 1 whole square. Now we have to prove that their difference is divisible by x minus 1 whole square. Now we have to simplify this expression, x to the power n plus 1 minus n plus 1 into x plus n plus 1 minus 1 minus x to the power n minus nx plus n minus 1 is simplifying it and we get this is equal to x minus 1 into x to the power n minus 1. Now we know that x to the power n minus 1 is always divisible by x minus 1. Therefore we know that x minus 1 into x to the power n minus 1 is a factor of is a multiple of x minus 1 whole square. Therefore, we have proved that the difference of tn minus 1 and tn is divisible by x minus 1 whole square. Therefore, tn plus 1 must also be true. Therefore, the given statement t is true for any value of n greater than 2, thus proving our proposition. Thank you.